Okay, now verifying trigo identities. Okay, so you know that x square minus 4 is x minus 2 x plus 2.
Yeah.
Correct? No matter what x is, this is called an identity.
Yeah.
Identity is always true.
Yeah.
X square minus 4 is 0 is not an identity because it's true for some values of x.
Yeah.
But not for others. So this is not an identity.
Right.
So identity is something which is always true. Correct? So if you think of this factorizing a cube minus b cube, a minus b, a square plus ab plus b square is an identity.
Yeah, we were.
And a formula.
Yeah.
Okay. Now trigo identities we have. Now we know that if an angle is in standard position with terminal side, this is my terminal side. Okay, intersecting the unit circle at x comma y, then your x is equal to cos theta. You know that?
Yeah, I remember.
X is always cos theta. Unit circle x is always cos theta and y
then
sine
the
theta.
hypotenuse is 1 because of.
Do you remember the equation for the unit circle?
X squared plus y squared is equal to 1.
Perfect.
But it would be cos squared plus sine squared.
Correct. So x squared plus y squared is equal to 1. So if you substitute then, so if you replace the variable, what will it become?
Cos squared.
Cos squared
theta
plus sine squared theta is equal to 1.
Yeah.
Correct?
Makes sense, yeah.
It's called a trigo identity. Pythagorean trigo identity.
Yeah.
So note that sine square theta is used in place of sine theta the whole square. It means the same thing.
Same thing. Huh?
Use direct substitution to show that the Pythagorean identity holds true when theta is equal to 5 pi by 6. So when you substitute it, direct substitution, so what we have is sine square 5 pi by 6, correct? Plus cos square 5 pi by 6. You have to prove that this is equal to 1.
How come? Oh, both are 5 pi over 6?
Yeah, theta, no? The theta.
Because theta, there's
the
both
theta, both the thetas are replaced by 5 pi by 6.
Right.
And you have to prove that this is equal to 1.
Right.
Direct sum.
Okay.
Now, what is sine 5 pi by 6?
That is 5
pi by 6. Now see, you have to
150.
square it.
That 150.
Plus cos 5 pi by 6. Correct? You have to square it.
Yeah.
Yeah, now pi by 6 is 30. Yeah, so 150.
150. Yeah.
So sine 150 it will be same as what?
30.
Sine 30. And what is the value of sine 30?
Oh, square root of 2 upon 2. No, that's 45.
Half.
Half, yeah.
Correct? So this will become half square because that's sine square.
Right.
Plus cos 5 pi by 6 is cos 150.
Which is cos 30.
Minus cos 30.
Right, minus cos 30.
All silver teacups in the second quadrant.
Right. Because 150
so
all.
Minus root 3 by 2.
Ooh.
So minus root 3 by 2
squared.
So that's 1/4 because 1/2 squared is 1 square. 1/4
plus 3 upon 4.
Okay. That's 4 upon 4.
Which is equal to 1. So you just need to prove it.
Prove it, yeah.
Prove it. I like these questions.
They won't come. They'll never come.
No?
No.
Too easy?
Too easy. I mean, it's just to build up the concept.
Yeah.
The Pythagorean identity also provides alternative method for solving problems like the one below, which is previously solved by drawing a right angle triangle.
Right.
So you remember what we did previously? Sin theta is 4 by 5. We do a right angle triangle.
Yeah, and then
theta,
and then you can do cos.
Correct. You completed Pythagoras theorem.
Right.
And you do SOHCAHTOA.
SOHCAHTOA, yeah. That was nice.
But now, using the Pythagorean identity.
So
sin square theta. So what will I do?
Sine 4 over. No.
Sin square theta.
Sine, squared.
Plus cos square theta is
equal to 1. Yeah.
Now what is your sin theta?
Is equal to 4 over 5. So sine
4 over 5
4
square.
over 5. Yeah.
Plus cos square theta is equal to 1.
Right. Sine theta as a whole is equal to 4 over 5, right?
Sine theta whole is 4 over 5.
Not the angle. So you do 4 over 5 squared.
4 over 5 squared.
Plus cos squared is equal to 1.
Yeah. Now you solve for cos.
So that'd be 16 upon 25.
Cos square theta is 1 minus 16 over 25.
So then you multiply that by
9 over 25.
Yeah,
right?
9 over 25.
So cos square theta. So cos theta is equal to what?
Cos theta
plus
is
or minus?
Plus or minus 9 over
3 over 5.
3 over 5. But it would be minus.
Why?
Because of the domain restriction.
Correct. Domain restriction. So
also
this is 0,
teacups.
pi by 2 pi. So this is in the second quadrant.
Yeah, where cos is negative.
Negative. Therefore cos theta is equal to what?
cos theta is equal to minus 3 over 5. Nice. It's easy actually.
Yeah. Now, verifying trigo identity is one of the few things that make trigo such a rich area of mathematical study. Is there are so many identities giving different relationship between trigo functions. We are already familiar with the reciprocal identities. For the review, it's again put in your reciprocal identities. Your cosec theta is 1 over sin theta.
Right.
Your sec theta is 1 over cos theta.
Right.
And cotangent theta
1 over 10.
and cot, that is 1 over 10. So remember, reciprocal of C is S. S is C. And cot,
I remember
tangent
this.
is there.
Cot, T at the end, tan.
Yeah, tan. Yeah.
I already remember that.
Okay, good.
I don't know.
Excellent. Very good. Tangent and cotangent identities. Tangent theta is sin theta over cos.
X over
and
Y.
cotangent theta is cos over sec.
Opposite. Inverse.
Reciprocal. Reciprocal is the correct word.
Yes.
Co-function identities. Co means complementary.
No.
Sin pi by 2 minus theta as cos theta.
Yeah.
Cos pi by 2 minus theta is sin theta.
Just something to remember.
Yes, you have to learn it up.
Yeah.
So they are their co-functions. Co-function of sine is cos, co-function of cos is sine, and co-function of tangent is cotangent.
Only when it's pi over 2 minus theta.
Only pi over 2 minus theta or odd multiples of pi by 2.
So like...
that will come to that later. Right now just for
okay,
this.
Yeah.
Right now just remember this. For beginner step, this is good.
Okay, yeah. Beginner stuff, yeah.
Beginner level. So when we go to little advanced level, it will be there. But we need not worry about that. Now, using appropriate identities simplify the expression.
Yeah.
So what's your...
So tan, that is equal to cot theta into sine theta.
Yes. Now what's the cot theta? Now see, remember, you have done proteins?
Proteins.
In bio? You're doing bio?
No, I don't know bio.
I
know
proteins, the basic building blocks of proteins are amino acids.
Right, yeah.
So basic block of any trig function is sine and cos. You don't know anything, convert everything into sine and cos.
Sine and cos, yeah.
So that's your basic building block. So what's your cot theta?
Your cot theta is y upon x.
No, now you forget y upon x. What's your cot theta?
Sorry, cos upon sine.
So you see in terms of cos and sine.
Right.
Because you're not doing unit circle.
Right, okay.
And
it's just muscle memory.
Yeah, muscle memory.
Times sine and then cancel, so you get cos.
That's how you simplify. So
like
you convert everything into sine and cos. These are your basic building blocks.
Amino acids.
Amino acids, yeah. Okay, start.
Okay, so
cosec
is 1 upon sine theta.
Basic amino acids. Basic building block.
Basic building block, yeah.
Okay, and what's your cot theta? Cot square theta?
Cot squared theta is cot 1 over tan theta squared.
No. Right in terms of basic building block.
Oh, cot theta. It would just be 1 over cos theta upon sine theta. Yeah.
Tan is not a basic building block.
Right.
So what will you write? Cos square theta upon sine square theta.
Yeah.
You got the idea?
Because it's squared, so both are squared.
Plus
1 upon sine theta.
So now this will become cos square theta upon sine cube theta, correct? Plus 1 over sine theta.
Right.
If you take LCM,
you multiply that by sine squared theta.
Perfect. So you multiply this by sine square theta.
Yeah. So then you add it.
So cos square theta plus
sine squared theta
upon
sine cube theta.
Perfect. And what is cos square theta plus sine square theta?
Cos squared theta.
First identity that you learn in your life in trigo.
1. Right. Sorry.
So
1 over sine cube theta. Okay. Simple actually.
But convert everything into sine and cos.
Okay.
And then everything will fall in place. There's nothing.
It is nothing.
Yeah, it is nothing. There are actually 2 more Pythagorean identities. You can derive them quickly from sin square theta plus cos square theta is 1
Hmm.
by dividing both the sides either by sin square theta or by cos square theta. So let's see this. So if I divide this by sin square theta,
Yeah.
divide each term by sin square theta,
Okay.
what will this become?
So sine
This
squared
will
theta,
become
sine
1
squared theta cancels.
plus.
Yeah.
What is cos square theta upon sin square theta?
Cos squared theta upon sine squared theta. That's cot squared.
Theta
Cot squared theta, yeah,
is equal to
1.
1 over sin square theta.
Oh yeah, 1 over sine squared theta.
What is 1 over sin?
1 over sine is CSC.
Cosec.
Cosec.
Cosec square theta.
Yeah.
So this is your other Pythagorean identity.
Okay.
1 plus cot square theta is equal to cosec square theta.
Something, another identity.
Like sin square theta plus cos square theta is 1.
It's interesting because
Yeah.
it's
Now-
like the AQ minus B.
Correct. It is the identity. Now you divide by cos square theta. So suppose
So
you divide
that's-
everything by cos square theta.
Yeah. So that would be tan, right?
Yes, very good. Tan, so what do you write?
Tan squared theta
Uh,
plus 1
uh,
is equal to 1 upon cos theta,
uh,
which is SCC, right?
correct. Sec
Sec.
square theta.
Yeah, sec squared.
Why
Wait,
is it
squared?
lagging?
Yeah, squared.
Why is it lagging? 1 second. Okay. Now, so the three Pythagorean identity have been given over here.
Mm-hmm.
Okay, your sin square theta plus cos square theta is 1. 1 plus tan square theta is equal to sec square theta.
Yeah.
And 1 plus cot square theta is a cosec square theta.
Hmm. So then,
You have to learn these up.
yeah. So then, what you could do is.
Nothing you have to do. You have to learn this and apply this.
Okay,
That's
just that. Okay.
So you may not remember the derivation.
I just have to.
It's better that you remember,
Yeah.
but more utility will be learning and applying this.
First applying it, then I can memorize. Yeah.
Then you can learn. Now this one.
So this one is this one, right?
Correct.
So you could
So 1 plus cot square theta.
Wait, where is that? It's here. Sorry.
So 1 plus cot square theta
Yeah, 1 plus.
is equal to cosec square theta.
Yeah.
Correct? Substitute.
Because you just squared
So 1 plus
So 1 plus 4 over 3 squared.
cot square theta. No, cosec.
Yeah. Cot squared theta is equal to 4 over 3. Right. Sorry, because cosec is equal to 4 over 3.
So 1 plus cot square theta.
Is equal to 16 upon 9.
Therefore cot square theta is
1
equal
minus.
to 16 upon 9 minus 1.
Right.
So cot square theta is equal to. So 16 minus 9 is?
16 minus 9 is 6. 7.
Correct, na?
Yeah.
So cot theta is equal to plus or minus root 7 by 3.
Yeah.
Yeah?
Yeah.
So your cot theta is equal to plus or minus. So what will you take? Will you take plus or minus?
So the domain restrictions are 90 to 180
So all silver teacups.
teacups. It would be
So 90 to
negative.
180. Very good.
So negative 7 over 3. Square root
So
7 over 3.
correct. So cot theta is equal to, very good.
Yeah.
Minus. Correct?
Yeah.
Now, we can use trigo identities and standard algebraic techniques to manipulate trigo expression. Now, this is very important. So, keep those identities in front of you. And where's the other one? That also. So, all this. Keep all this in front of you now.
Okay.
Cos square theta minus 1.
So cos squared theta minus 1.
Look at these identities.
Huh.
Look at these identities. Which one will you apply?
Cos squared theta minus 1.
You know that
This one,
sin square theta
sine squared theta
plus
plus
cos
cos
square
squared theta is equal to 1.
1.
So then,
So then if you transfer it,
transfer
so
you
suppose
get
if you
cos squared theta
minus 1
minus 1
is
upon
equal to minus sin square theta.
minus sine squared theta, yeah?
Now there's one thing you can do. You can load it up. You know that sine square theta plus cos square theta.
Is equal to 1.
So what's your cos square theta?
Cos square theta.
1 minus sine square
1,
theta.
yeah.
And what's your sine square theta?
Sine square theta would be
1 minus cos square theta.
right. Another identity.
No, it's just the same identity rearranged.
Right. Okay.
So sine square theta plus cos square theta is 1. So what will your cos square theta be?
1 minus sine square theta.
And what's your sine square theta?
1 minus cos square theta.
So if you learn this up, then it becomes easier for you to do it.
Yeah.
So then your cos square theta, you can write it as 1 minus sine square theta.
1.
Cos square theta is 1 minus sine square theta.
Right. 1 minus sine square theta. Yes. Okay, I see.
So suppose you don't want to do it this way. Suppose you learn that up. So always when it happens, what's your cos square theta?
1 minus sine square theta.
Minus 1. So when you open the bracket, plus 1 minus 1 cancel. So you're left with minus sine square theta.
Right.
You can do it like this.
Solid. I like that.
This one.
Cos cube.
Now remember that whenever you can always substitute for squares using this identity.
Yeah. But
So
not
cos cube, you can't do anything.
You can't do anything,
because there's no identity with cube.
Right. Yeah.
So cos cube theta plus cos x and sine square x. So only your sine square x can be written as.
Sine squared x will be equal to 1 minus cos squared theta.
Correct.
Cos
So 1
cubed.
1 minus cos square x.
Yeah.
Open the brackets.
So that would be cos x minus
Cos cube x.
Yeah, cos cube x. Sorry.
Plus cos x.
Cos x
Minus
cos cubed x.
Correct.
Yeah. And then those two cancel, so it's cos x.
Correct.
Nice.
So, but you have to remember the variation. How do you rewrite this?
Yeah. That's the thing.
And you substitute for squares. That you
only
remember.
squares, not cubed or anything.
Cube, there's no formula for cube. No? There's
Right.
no formula for cube.
No formula, yeah.
Now,
Sine A upon tan A. So sine is
sine A, nothing you do. Sine A
Sine-
is a basic building block.
yeah, basic building block. But
Divided by
then divided by tan, which is cot, or
tan.
divided by tan.
What? Look at your formula.
Sorry, sine upon cos.
Divided by
Yeah.
sine A upon cos A.
And then
So sine A into cos A
Cos
upon
A.
sine.
Divided by. So then those two cancel. You get cos A. Nice.
Factorize. 1 minus sine square theta.
Okay. So 1 minus sine squared theta, we know that that's cos.
No, they want you to factorize.
Factorize.
They don't want you to use the identity and make it right cos square. You're right.
Yeah.
You can say that 1 minus sine square theta
Is
is
cos square theta.
Yeah, but they don't want that. They want
They want
you to factorize.
So a squared minus b squared. So 1 minus sine, 1 plus sine. Yeah, that's it. Very easy.
Next, factorize.
2, no.
Can you remove common factor?
You can remove x.
No x. How can you remove x?
Sorry, sine.
Sine x.
Sine x, huh?
Remember,
Oh, yeah.
sine x is one term.
Right, yeah.
You sine is not sine
Right,
multiplied by x.
you can't do that, huh?
So what will be left from the first term?
Sine x 2
2.
squared.
So no, listen. You have 2. The sine square x is basically sine x the whole square.
Okay.
So what will be left with? 2 sine x?
Minus 1.
Correct. 2 sine x minus 1.
That's the most you could factor.
Yeah, that's you can't do anything more.
Wait, what did you write? 2, 5?
2 sine x.
Oh, sine. Sorry, I know that.
That looks like 5.
To me, maybe. I'm just wrong. No, it was sine.
Okay.
Okay. Nice.
Verifying trig identities.
He said this will come on the summative.
Yeah, this will come in the summative. So see, these are the sums that we have to just simplify it. You can do from the left hand side to right hand side.
So cos theta plus sine. So you could just write it off.
Start with the left hand side.
So cos, you just make the brackets, right?
Open the brackets.
Okay.
So what is cos?
Cos 2
theta
cos squared.
What is a plus b the whole square?
A plus b is a squared plus 2ab plus b squared.
So that only you
So
a square
cos
plus
squared
2ab plus b square. Same logic you apply.
Yeah. Okay. So a squared would be cos squared, cos theta squared, plus cos sine
2 cos theta
2
sine
cos
theta,
plus b squared. So sine theta squared,
sine
squared theta, plus
plus
cos squared theta minus 2 cos sine theta
cos theta sine theta plus
sine theta
sine square theta. So this and this cancels.
Yeah, so you get cos.
So what is cos square theta plus sine square theta?
1
plus
sine squared theta.
Cos square theta plus sine square theta.
Oh, 1. So 2.
Which is your right hand side.
Yeah. He said that he hates grading these questions because people can easily just lie because they already have the answer, so they make something up.
Now, which side you should start with? Left hand side or right hand side?
Right, because it looks more messy.
Messy. So that's because you can simplify. So start with the right hand side.
Okay.
So what will you do? Convert everything into sine and cos.
Sine and cos. Yeah. That's all you have. The amino acids.
Amino acids. Yeah. Protein. There's so many types of proteins.
There's so many proteins. Yeah. A to G. I forgot all about it.
So what's your sec?
So sec is 1 over cos theta.
1 over cos x. If
Cos,
they have x, you use
right.
x. Cosec?
1 over sine. Minus
sine x over cos x.
Yeah.
So that is equal to, now take the LCM. What's my LCM?
You could take sine and cos. Sine 2 sine cos x. Yeah.
Correct. You multiply the second term. It didn't have a sign.
Yeah.
So then this becomes cos x, sin x, and what will my numerator become?
Numerator would be 1 minus
1 minus
sine squared.
What is 1 minus sine squared x?
1 minus sine squared is cos theta. Cos squared theta.
Very good. Learn that up.
Yeah.
That is also very important.
Yeah.
Cos square x
upon cos
x
sin x.
Now
you can cancel.
So you're left with cos over sine.
Cos over sine. Yeah.
What is cos x over sine x?
Tan.
No. Cot.
Cot. Sorry. Cot.
Cot x.
Cot x.
And that's your left hand side.
Is equal to Oh, very nice.
So you can start from the left hand side, reach the right hand side, or you can start from the right hand side, reach the left hand side.
How would you start with the left hand side?
No, you can't. No, there's nothing you can do.
You can. You always go for the messy side. Right?
Yeah.
That's what I thought.
Yeah.
Oh,
no, you're what will you start with?
Clearly the left side.
Yeah. No.
So, we know this. Cos pi over 2 minus theta sine, right?
Yeah.
So that's
co-function identities.
Co-function identities.
So this will become sine theta.
Oh, and then the bottom would become?
No, it will remain 1 minus.
It remains.
It's not 1 minus cos square theta.
I was thinking
minus
sine theta
upon 1
plus and then cos
theta.
Cos theta, right.
Now you take LCM.
So you can,
So this will be 1 minus cos theta, 1 plus
cos theta. So that becomes sine.
Numerator sine theta.
Yeah.
1 plus cos theta.
Yeah.
Minus sine
That's
theta. Correct. Now what do you do?
Now you open the brackets. So sine theta plus 2
sine theta cos theta
Sine theta cos theta
minus
sine
sine
theta
plus
plus sine theta cos theta.
and denominator?
Denominator is, you can just write it like that, no?
No.
Okay.
What is a minus b into a plus b?
A squared minus 2ab plus b squared.
No.
Sorry.
What is a minus b into a plus b?
A squared minus b squared.
Yeah.
Hmm.
So algebraic identities you have to know well. So this is like your a minus b into a plus b.
Right. So that's a squared, which is 1.
Correct?
Yeah.
Now your sine theta cancels out. So what are you left with?
So you get sine 2 sine theta cos upon sine.
Upon
2 upon sine squared.
Sine
Sine
squared
squared theta.
This and this cancels out.
So it becomes 2 cos theta upon sine theta. Further.
What is cos theta or sine theta?
Cot. So 2 cot theta. Very easy. If you just understand it.
Yeah. The next important thing you need to remember, and here the last set of identities for today. Negative angle identities, also called opposite angle identities. Your sine of minus theta is same as minus sine theta.
Yeah.
So it's an odd function. Cos of minus theta is cos theta. It's an even function. So no matter whether your theta is positive or negative, your cos value will be the same.
That's weird.
Example, your cos of minus 30 degrees will be same as cos of 30 degrees.
Okay. And then here, if it's cos of minus 30, it stays as
minus cos 30.
Minus cos 30. Huh?
So cos of minus 30 will be minus half.
Right. No, sine of minus 30.
Sine of minus 30 will be minus half.
Right, minus half. Okay.
And cos of minus 30 will be root 3 by 2.
3 by 2, yeah. And then tan of 30.
Yeah, so
say
tan of minus theta, tan
minus
of minus tan. So odd function, even function, odd function.
Okay, that's strange. But yeah.
Verify the identity. Sure.
Oh my god.
Left hand side, let's start.
Okay, so 1, it's not squared.
So 1 minus,
1
now what is cos of minus x?
Cos of minus x is positive, so cos of x.
Even function, correct?
Mm-hmm.
Now what is sec of minus x?
Would it also be...
Look at your, this one. Your sec.
Yeah, no, my sec is cos, so it would also be
cos.
positive.
Correct, very good.
I knew it was cos, I was just making sure.
Yeah, correct. Good. Good application. So that's the logic.
Yeah, okay.
Behind the scenes, yeah. Correct?
Yeah. So 1 plus sec theta, or x.
So 1 minus cos x, correct?
Mm-hmm.
1 plus 1 upon cos x.
Mm-hmm.
So take LCM.
So cos x.
Cos x plus 1.
Yeah. So there you can multiply that by cos x.
So 1 minus cos x.
Mm-hmm.
1 plus cos x.
Yeah.
Upon cos x.
Mm-hmm.
So what is your a minus b into a plus b?
A minus b into a is a squared. So 1 squared.
1 squared minus?
Minus b squared. So minus cos x. Cos squared x.
So what is
so that cancels. So
no, it doesn't cancel. How can it cancel? There's a minus sign. What is 1 minus cos squared x?
Oh, it's positive.
What is 1 minus cos squared x?
Sine squared theta.
Very good. Sine squared x.
Oh, I like
cos x.
I like this.
Now further, see you have
so
to
now this
listen. Now you can leave this here. I'll show you another method. Now you can also do right hand side separately then. What's your right hand side?
Tan x, sin x.
What's your tan x?
Sine upon cos.
Sin x over cos x.
Into sin x.
So that's your sine square x.
Yeah.
Upon cos x.
Mm-hmm.
So the same thing.
Yeah.
Therefore left hand side is equal to right hand side.
Nice.